Good afternoon, everybody. I'm Clint Kelly, and I'm here today to talk to you about Kiji. This is a platform that you can use to build big data applications on top of Cassandra. So for the next 30 minutes or so, I'm going to talk about a few things. First, I'll describe the problem we're trying to solve with the open source Kiji project. That is, I'll describe what I mean when I say a big data application. I try to reduce the jargon as much as possible. And then I'll talk about how Kiji works and how you can use Kiji to solve this problem. That is how you can more easily build one of these applications. I'll talk briefly about how Kiji works in production right now. So we're using it to serve personalized recommendations with a top or a Fortune 150 retailer at the minute. So I'll describe how that works. And finally, I'll talk a little bit about how Kiji works on top of Cassandra, how we map our data model to Cassandra, what some of the pitfalls were with adding Cassandra support this year, and so on. All right, so first, the problem. Let's say that you want to build a big data application. I've shown a few canonical examples of these applications here. If you want to be a little bit more specific, let's say that you work at a retailer somewhere like Best Buy, you want to serve personalized recommendations on your site. The most straightforward way to personalize recommendations is to look at whatever's in a given user's shopping cart. So for example, if I add an iPad to my shopping cart, it probably makes more sense to recommend to me an iPad case or a cable rather than a dishwasher. We can also personalize it by doing things like looking at my recent activity on the website, or a customer's recent activity on the website. If I spend a lot of time looking at product reviews, then it makes sense to recommend to me items that get 4 or 5 stars. If I spend a lot of time using price filters, I might want to recommend less expensive items. And likewise, we can look at my search history or how I've interacted with a mobile version of the application to further customize my experience. There's a little bit more detail about what we want to build, a kind of concrete example. How do we go about doing this? A good place to start is with all of the great, proven, super scalable, open source big data software that's out there. To begin with, we need a place to record all of these customer interactions with our site. And as you guys have heard all day today, a great place to do that is in Cassandra. It's perfect for this kind of high volume time series data. Afterwards, we need a way to run some kind of analytics over all this kind of data. A natural choice for this is Hadoop. Those of you who are just next door know that you could also use Spark. And then there are all kinds of other projects for doing things like running SQL on top of the data in Cassandra, serializing and deserializing, describing more complicated MapReduce jobs, and so on. So there's a lot of great software out here. It's in production everywhere. We're also fortunate to have companies like DataStax that package all of it together in an enterprise-ready solution for us. There's still a lot of functionality that we have to build to get from all of this scalable open source software to our final big data application. So let's talk a little bit more about what that functionality entails. To begin with, we need a way to get data from our application into Cassandra. We may design our applications such that we record user interactions in flat log files or relational databases. In this case, we can use Hadoop to batch load all of this data into Cassandra. Ideally, we use some kind of a RESTful interface so that we can stream user interactions with our application directly to Cassandra as they occur. In any case, once we have this data in our system, we'll have some data scientists on our team who are probably going to want to inspect this data and then run some analysis to improve our application. Data scientists want to use languages and tools they're familiar with. So in designing our application, we'll want to have a component like Hive, for example, that allows a data scientist to use SQL. Once the data scientist has this data out of our data store, they'll probably use language or a tool like R or Python to analyze it. After analyzing it, they'll gain some kind of brilliant insight that they can use to improve our application. Use this insight to build some kind of a machine learning model, or to tweak some kind of machine learning model. For any of you guys who've worked with machine learning models before, once you've developed it, you need to train it. And this is the trained machine learning model here. And when you train the machine learning model, again, if you're a data scientist, it's very straightforward to use a tool like R and Python that has a really nice interface that's easy to use. But these tools don't scale out to the high volume of data that you can store in a system like Cassandra. Hadoop is a great option as far as scalability goes for training machine learning models, but it's not the most usable tool in the world. We probably don't want our data scientists writing mappers and reducers all day. So when building our application, we'll want to choose some kind of technology that tries to provide a good trade-off between the usability of tools like R and Python and the scalability of Hadoop. As an aside, when we talk about this machine learning model, we can think of it as, after it's trained, we can think of it as a function. Its input is all of the information we have about a given user. An output of this function, in this case, is a set of personalized product recommendations. It could just as easily be a decision about what content to show a user on a splash page, whether or not to offer a user free shipping or to send him a mobile offer when he enters your store on his iPhone, things like that. In any case, we have this trained machine learning model, and our next step is to use it to generate these recommendations for our users. We call this process scoring. One way to go about scoring is to do so in batch. We could generate a Hadoop job in which we read all of our data about all of our customers out in MapReduce, apply our machine learning model to all of these users, generate new recommendations, and write them back to Cassandra. And this would be a batch operation. So there are some downsides to this approach. If we generate recommendations in batch, it makes it pretty hard to respond to very quick changes in how our user is interacting with our application, like changes in the contents of a user's shopping bag, for example. We'll talk in a second about how to do that. Finally, we need a way to get this data out of Cassandra and back to our application. If we already have a REST interface, it's pretty straightforward to use this for reading as well as writing. All right, so to review where we are right now, let's say we have a user. He's interacting with our application on his computer, and he visits a web page that has some real estate in it for product recommendations. When he visits this page, our application will talk via REST to Cassandra and do a read on some column that we know contains recommendations. We previously wrote these recommendations into Cassandra, doing that batch Hadoop job, scoring job I just described. So Cassandra sends the recommendations back via REST. The application renders them on the screen, and our user sees them. So now let's see how we can improve this. Again, we have a user interacting with our site. It goes to a page with recommendations. The application talks to Cassandra, fetches the latest recommendations for this user. Now, however, we add a thin layer of application logic around Cassandra, and it sees that our application is making a request for a column that contains these product recommendations. This application logic triggers a real-time scoring phase. So it takes the machine learning model and applies it on whatever the latest data is we have in Cassandra about how our user is interacting with our application. And this way we can generate product recommendations that are the freshest possible. So now we write these back to Cassandra. Cassandra sends it back via REST to our application. We render it on our user screen. And this time, hopefully, these are more relevant recommendations and we're likely to see a better conversion or lift or whatever metric. So of all this functionality I've just described, we can look at it as falling into three main categories. First, we need a way to get data in and out of Cassandra from our application. For For this, preferably we'll use a RESTful interface. Our data scientists need a way to inspect the data in Cassandra and use it to train machine learning models. And finally, we need a way to perform scoring, preferably in real time. So this is a fair amount of functionality that we need to build on top of all of these big data, open source big data technologies to get to our final application. And with this in mind, to help bridge this gap, we developed this open source Kiji project. And it's not enough to get you from Cassandra and Hadoop to being Netflix. But the idea is that it has a lot of components there that can help you kind of avoid reinventing the wheel and building out a lot of the functionality I just described to you, and let you get a head start doing whatever, building whatever kind of functionality is specific and unique to your application. That's the quick summary of the problem we're trying to solve. Now I'll talk about how Kiji solves this problem and how you can use Kiji to more easily build a big data application. First, a little bit of history. We built Kiji at WibiData. This is where I work. We're a small startup company in San Francisco. We were founded by employees from Google and Cloudera, who had a lot of experience building these kinds of applications I just described and working with open source big data technology. I screwed up the order of my San Francisco slide. San Francisco in the summer. So how does Kiji work? At the heart of Kiji is a data storage system where your application can put all of its information about all of your customers. You can think of this storage system as sitting on the border between your engineering and data science groups in your company. For the engineers, we provide ways to get data from your application to and from the storage system. For getting data into your storage system, we provide, as we just described, ways to take flat logs or data in relational databases and bulk load it using Hadoop MapReduce. We do this with a component called Kiji MR. We also provide a RESTful interface called Kiji REST that your application can use to get data into Kiji, as well as to read it back out. We call this storage system Kiji Schema. It sits on top of Cassandra. You can think of it as containing one row for every user of your application, and then within each row containing lots and lots of columns with what you've purchased, what you've clicked on, your impressions, hovers, and so on. For the data scientists in your team, they can query the data in Kiji using our Hive adapter, Kiji Hive. Once they have this data out, they can analyze it with standard data science tools like R and Python, gain some kind of brilliant insights about how to improve the application, and then use those insights, or take those insights and apply them to some kind of machine learning model. As far as training goes, within Kiji, our Kiji MR component, we have a library of common machine learning algorithms like k-means, naive Bayes, collaborative filtering, and so on. For data scientists who are not super comfortable with Java, we have Kiji Express. This is built on scalding. I'm not sure if any of you guys are familiar with that. It's an open source project from Twitter that provides a high-level language on top of MapReduce. It lets you describe MapReduce computation or complicated chains of MapReduce computations very concisely using a language that looks a lot like functional programming operations on Scala's collections library. In any case, once we've trained this machine learning model, the next thing to do is to apply it via scoring. In Kiji, we have a notion of a score. A score uses information about a user and some kind of trained machine learning model to generate some derived customer insight, whether it's, again, personalized product recommendations or something else. The data scientists can apply the score in batch using Hadoop, but as we just discussed, that's not the best way to go about doing things. So to this end, we have a couple of additional components. Kiji scoring, and the Kiji model repository. So now I'll show how we can use these components to enable the kind of optimal real-time functionality I described 5 minutes ago. So let's say again we have our, well, first thing, the data scientist, once he's happy with his model, he wants to deploy it, he uploads it to our model repository and then makes this, the associated score live. So once the score is live, if we have a user, again goes to the site, comes to a page, comes to a page that has space for recommendations. We'll query Kiji via REST. Kiji scoring is that application logic that sees the request for recommendations and triggers the appropriate score sitting in the model repository to apply our machine learning model in real time. So the score will take the appropriate data from Kiji's schema about a user, generate a new product recommendation, write it out to the table, and the table will send it via REST back to our user, and he'll see the recommendations. One other thing about this, the model repository and Kiji scoring, that's kind of nice. These also enable data scientists to more easily run different kinds of experiments. So data scientists will usually have lots of different variants of a given model. They can use the model repository to bring different models on and offline really easily, set up experiment frameworks, run A/B testing, and so on. So to review, there were 3 main kinds of functionality we talked about needing to build for a big data application. First, you need a way to get data in and out of Cassandra. To this end, we have Kiji REST and Kiji MapReduce. Second, we wanted a way for our data scientists to be able to inspect the data in Kiji and use it to train machine learning algorithms. For this, we have Kiji Hive, Kiji MapReduce, and Kiji Express. And finally, we want a way to be able to do scoring in real time. And for this, we have the model repository and Kiji scoring. Excuse me. One final note about the Kiji architecture I've just shown. It's highly modular. This was one of the main design goals when we were building Kiji. So let's say some of you guys might have applications that look something like what I just described, but maybe you're doing something beyond that, or you're doing a subset of that. You can just take whatever components you need for your particular use case, and also easily build out additional ones. If you want, a lot of people today, for example, have talked about doing streaming computation when you're ingesting data. It's pretty easy to write another component using Storm or Spark Streaming and plug it into this infrastructure. Okay, so next, talk about how Kiji is used in production. A couple of use cases I chose to highlight here. First, I'll talk in a second about how one retailer is using us for personalized recommendations. Another kind of cool use case, because it's not recommendations, is OPower. They recently went public. They're an energy company. They monitor, I don't know if you guys get this in New York too, but in California, whenever we get an energy bill, there are lots of graphs in there and analytics about how much energy you're using relative to your neighbor, what you can do to save power, and so on. And all that comes from OPower. And they aggregate all of the usage data for all of their customers and all their power meters or whatever, and run analytics on those and generate those graphs using Kiji. All right, so the Fortune 500 retailer uses Kiji for personalized product recommendations. If you're really curious who it is, you can just go to kiji.org. We have their logo on our website. Anyway, so first, when they're using Kiji, they bulk load. This is a big retailer, so they have a lot of legacy infrastructure for recording customer interactions, product catalogs, things like that. So they use Kiji MR to bulk load all of this data into their Kiji tables. The data scientists there use all the same tools we just described. So when we're training the machine learning models with this retailer, we use Kiji MapReduce and Kiji Express. Finally, the application communicates with Kiji via REST and uses Kiji scoring for generating these recommendations based on what the latest items are in a customer's shopping bag and so on. Finally, now I'll spend the next 10 minutes or so talking about how Kiji runs on top of it. Oh yeah, sorry, go ahead.
So the scoring happens in real time?
Yes, yeah. Excuse me, so when a customer adds something, or if you're a customer on this website and you add something to your shopping bag, we reapply the machine learning algorithm every time your shopping bag contents change. Yeah.
Instead of scoring, can we use it for fraud detection?
Yes. So this, yeah, that's a good point. So I'm just kind of using retail here as one example of what you could do with this because it's kind of a canonical example in this field.
Because it's based on what you do on the backside with the machine learning.
Yes. Yeah, so it's really just a real-time application of a machine learning model. So fraud detection is definitely one of the biggest applications for this kind of infrastructure. And it's one of our kind of WibiData target markets.
Do you have any clients?
We have someone who's using this in production in the finance industry, but I'm not sure if they're using it for fraud detection or not. But it's certainly applicable. I mean, anything where you train a machine learning model in batch and then apply it in real time based on however, some entity, whether it's a customer or a power meter for O-Power or anything else based on its current state, you can use this system. Yeah, I talked to someone at, I think, Hadoop Summit who wanted to use this for semiconductor manufacturing and running machine learning models to figure out whether or not it looked like wafers would have errors in them or not, and then in real time decide whether to bring them on or off the manufacturing line. Yeah, if you have more questions about that, we can talk about that. Yeah, sure.
The retailer use case, right? So what happens offline? That's what is real time you do the scoring, but
yeah.
Do you do anything offline, like in the batch process?
Yeah, so offline is really using training. The model in this case uses item-item collaborative filtering. I don't know if you guys are familiar with that or not. It's like a standard kind of recommendation algorithm for something like a shopping site. You calculate the similarities between different items based on how often the same people like them or purchase them or whatever. So then if you have like 5 items in your cart, for those 5 items, you get the most similar items, and then add up their similarity scores and sort them, and that's usually what you recommend something with a bunch of tweaks in there for business.
Does that happen on a nightly basis? Or?
So rerunning I'm not sure how often we rerun the collaborative filtering. Probably, there's no reason you couldn't do it every day. Yeah. Anybody else have any other questions? Okay, yeah, feel free to interrupt me. I'm talking over caffeinated. So. Okay, so now I'll talk about how we updated Kiji to run on top of Cassandra. One thing I should mention here, we originally built Kiji. It worked on top of HBase. We've seen such strong demand in the community for people using Cassandra that we worked this year to have it run on top of Cassandra as well as HBase. So the data model that we use in Kiji is pretty similar to that of Bigtable. And since Cassandra is also inspired by Bigtable and DynamoDB, the data models for all 3 of them are pretty simple, which made adopting Kiji to run on Cassandra pretty straightforward. The data model, really quickly, we store data in tables. Tables are made up of rows. Rows have row keys and some data payload. In Kiji, we call the row key an entity ID. We support composite entity IDs, so every entity ID can have some hash and unhashed components. This is pretty similar in Cassandra to how you have your partition keys and your clustering columns and your primary key. The data in rows is made up of column families. In the column families, we further divide up into separate columns. Where our data model differs a little bit from Cassandra is that we have explicit support for distinct timestamp versions of the data in every column. Again, this is in line with the way that Bigtable does it. And the data that we store in each one of these columns could be any kind of complex record using data types like strings and doubles and integers. Then we also support maps and lists and recursive maps and lists and so on. We use Avro for data serialization and deserialization, so we're just storing Avro records in these columns. The other interesting thing about the Kiji data model is we support locality groups. So these locality groups are similar to column families in Cassandra. In Cassandra, every column family gets stored separately on disk. It goes in its own SS table. And in Kiji, we store all of the different group column families into locality groups. And then those each locality group gets stored separately on disk. So let's say if you had a bunch of column families in your application, maybe some of them you use more for batch processing, and some of them you use more for real-time processing. You might find that those column families that you're using for batch processing, you want those to just be on disk and compressed, whereas the ones you're using for real-time processing, you might want to have those cached in memory. You can group these different column families into separate locality groups and assign to the locality groups those properties. This provides kind of an extra level of indirection. You can use column families to organize your data logically, and then these locality groups to control how it's organized physically. Finally, in Kiji, we have a notion of a row as a unit of transactional consistency. I'll come back to this again in a second. All right, so now I'll talk about how we map this data model into Cassandra. It's pretty straightforward. I'll just show the CQL at the bottom that we use to build the Cassandra version of a Kiji table. So we start by mapping locality groups to column families. Again, this makes sense because we want them to be stored separately on disk. And they have a lot of the same properties that column families do in Cassandra. The entity ID we map to the primary key, and again that has some hashed and unhashed components. So those correspond to the partitioning key and the clustering columns. The family, the column family, the column name, which we call a qualifier, and all the explicit timestamps, we map again to clustering columns. And finally, the values of the columns are just blobs. They're just byte arrays. Because again, we're using Avro to serialize and deserialize all of our data.
That's not secure, right?
Yeah, it is.
Hopefully.
It is.
It might have bugs. Yeah. If you have any questions about it, I can.
None.
Oh, okay. So now I'll talk about kind of some of the issues we ran into. This mapping, for the most part, was pretty straightforward. But there were a couple issues we ran into which I think are kind of interesting. First, a couple implementation notes. We did use a data stacks Java driver for everything. I think right now we're using Cassandra 2.0.6, but we'll upgrade to 2.1 pretty soon. And we made extensive use of the async API in the DataStax Java driver, which was really awesome. The other thing is we spent a lot of time working on the Hadoop integration of Cassandra and the Cassandra version of Kiji schema. So we built, among other things, we developed a new input format, which has a couple additional features beyond the stock one. It's open source if anybody's interested. All right, so the issues. First, we need to support operations that cross different locality groups. So when we map this Kiji data model to Cassandra, we have, again, one locality group in Kiji maps to one Cassandra column family. And in Cassandra, you can't have a single atomic operation that touches multiple column families. So if we have things like a read in Kiji that crosses multiple locality groups, we had to break this up into multiple reads in Cassandra. And this is one place where, again, the async API was really huge because we can just fire off all those reads one after another and wait for them to all come back to assemble the data to send back to the Kiji client. Another thing that was pretty tricky is comparing sets across locality groups. The H-based version of Kiji allows these. I'd say if you're using this in your application, you're probably maybe need to design your application differently. But we supported these in the H-based version of Kiji. We just weren't able to allow them in the Cassandra version. If anyone has any ideas on how to support a compare and set across multiple column families, please talk to me afterwards. And finally, we had this notion of a row as a unit of transactional consistency in Kiji previously. So we've lost that in the Cassandra version. Again, for all the reasons I just showed. The other thing that was a little bit tricky, HBase has a very rich set of server-side filters. So when you're doing a query in Kiji, you can specify things like a regular expression for a column name or some kind of crazy regular expression or other check for the values you're reading back, and do all this filtering on the client, or excuse me, on the server. In Cassandra, we can do a lot of this we can do a lot of the common filters on things like qualifier names or timestamp ranges with where clauses, but it's not as flexible. So in this case, we've really just done all the filtering we can't do on the server on the client. We just warn the client that they're doing something that might be kind of expensive. We're looking into ways to do this on the server in Cassandra. It'll really just depend on whether we have applications in production using it. Okay, so in summary, there are three kind of main types of functionality we talked about for big data applications. First was getting a way to get data from your application to your data store and back. And again, for this in Kiji, we have Kiji REST and Kiji MapReduce. The second was having a way for your data scientists to inspect the data that's in Kiji or in your data system, then use that to train some machine learning models. For this, we have Hive, MapReduce, and Kiji Express. And finally, needed a way to do scoring in real time, so to evaluate those or apply those machine learning models, generate new product recommendations, or maybe some kind of fraud detection warning, for example. And for this, we have our model repository and Kiji scoring. One final thing, just want to say thanks to the Cassandra community. A lot of the guys on the mailing list, for example, I think are here or next door. Were really helpful. There's a lot of great information on a lot of stuff on YouTube from the events like this and Cassandra Summit. That was really helpful in getting started kind of from scratch. Cassandra. And finally, if you're interested in Kiji, you can try it now. So we have a nice kind of development kit you can use. We call it a bento box. It has an in-process or a single process Hadoop cluster with HBase on it. You can just untar something and get it running with one command. And we have a lot of tutorials that show you how to use Kiji Schema, Kiji MapReduce, Kiji Express, and Kiji Scoring. If you want to play with the Cassandra version in particular, we have kind of a beta version of the bento box and tutorial for that that's available at this link. We should have all of the components. This just has Kiji Schema, but we've tested all the components on top of Cassandra now, and we're just putting together some new tutorials that will be online soon. That's all I got. Anybody have any additional questions?